At most, how many Sundays can occur in a single calendar year? Well, let's say this is the first week in the calendar. And then, of course, you'll have a whole bunch of weeks. Let's say those are the 50 weeks. And then you have the very last week. So that is the, let's see here, the 52nd week. 52nd week. Okay, so let's talk about this. So if we have a Sunday in every single one of these weeks, so you had a Sunday here, all the way down, and then you have a Sunday here. That obviously means that there's 52 Sundays. Now, let's see how many days. Each of these weeks has 7 days, right? So we covered a total of 52 times 7 days so far, which is 364. But a year has 365 days. So there's one additional day, I guess, on top of those 52 weeks. And if that is a Sunday also, then we would have actually 53 Sundays. And that is the maximum number of Sundays that we can squeeze into one calendar year. The sum of 4 positive integers is 22. What is the largest possible product of these 4 integers? So I have a plus b plus c plus d is equal to 22. And I think this question is really just experimentation. Let's just see what happens. If I use, let's say, 5 plus 5 plus 6 plus 6, that would be 22. Now if I take the product, it would be 5 times 5 times 6 times 6, and that's 900. And then, like I said, you just keep experimenting. And what you'll find out is that if the numbers that you choose are close together, meaning they are as close to equal as possible, the product will be as large as possible. So you can kind of see that once you start experimenting. Like, for example, if I chose 2, 2, 2, and 16, that would equal 22. But if I took the product of those numbers, that's actually 128, which is significantly less than the 900. So the largest is actually 900, and happens when the numbers are as equal as possible. Each of 2 congruent circles passes through the center of the other, as shown. If the area of each circle is 16 pi, what is the area of the triangle whose vertices are the centers of the 2 circles and one of their points of intersection? All right, so let's blow this up a little bit. The 16 pi is what? Area of the circle is 16 pi. Okay, so that means that pi r squared is 16 pi. So that basically means that r squared is 16. So r is 4. So the radius is 4. So since this is the center and this is the end, that means this is 4. And this is also 4, and this is also 4, since those are also radii. So that basically is an equilateral triangle where each side is 4. And what do they want us to find? What is the area of that triangle? Okay. Well, the area of an equilateral triangle is equivalent to root 3 over 4 times s squared, where s is the length of the side. So this would basically be root 3 over 4 times 4 squared, which is, of course, 4 root 3. What are all 4 integers x greater than 0 for which the distance from x12 to the origin is an integer? Well, let's draw a graph and see what we can do here. So x12, okay, x12, well, obviously the y-coordinate is 12, and x is somewhere on this line, or y is 12. Okay, because x12 just means that we have some coordinate of x which is greater than 0. We don't know. And then the distance from the origin. So this is the origin right here. This one, 0, 0. And I don't know. So they're saying 4. So let's just say this is the first one, this is the second one, this is the third one, this is the fourth one. So the distances would be like from here to here, from here to here, straight lines like that. And those 4 lines have to have an integer in terms of their length. Okay, so let's just label them W, X, Y, and Z. And let's label this this point A12, this point B12, C12, and D12. And let's see what we get. So let's just start off with the first one, this first triangle right here. This one right here, like that. So we would have a squared plus 12 squared is equal to w squared. So a squared plus 144 is w squared. Okay, so what do I do now? I guess we have to just do trial and error. Is there an easier way or no? I don't think so. This is really time consuming. So basically you gotta go, okay, what is the value of A and what is the value of W, and see what happens. This is a Pythagorean triple, right? Pythagorean triple. So the easy way is if you've memorized Pythagorean triples, some of you have, like the most common one I think is 3, 4, 5, where 3 squared plus 4 squared is equal to 5 squared. But this one has a 12 squared. So if you have in your memory Pythagorean triples memorized with 12 in it, that'd be great. But if you don't, no problem. You kind of do it manually. You try A equals 1, A equals 2, A equals 3, A equals 4, and you won't get an integer value for W, but you will get for 5. When A is 5, W will be 13. And then you just kind of keep going. For 6, you won't get an integer. For 7, you won't, but you will for 9. For 9, you'll get 15, I believe. And then you kind of just keep going like that. And you'll find that the next two are 16 and 35, actually. And those numbers give 20 and 37 for the value of W. So I guess the x's that we're looking for, since this is sort of on the x-axis, were, I believe, 5, 9, 16, and 35. I drove at constant speed for 3 kilometers and traveled x kilometers. If I had driven each kilometer 1 minute faster, I'd have driven 30 kilometers further in 3 hours. What is the value of x? All right, before I get started with the actual question, let's give an example. It might be a little bit easier to digest instead of just jumping in with this x, because that x is a bit abstract. I think it's helpful if you have numbers. So let's give some numbers. Let's say, let me just extend this. I think I'm going to need one more box. Okay, so let's say you have a scenario where you're driving 90 kilometers an hour. So 90 kilometers per hour. And the time is 3 hours. Okay. So 90 kilometers per hour for 3 hours. That's actually a pretty big number. I think I'm going to change my mind here. I'm going to make it 30. Yeah. 30 kilometers per hour for 3 hours would be 90 kilometers. And the formula is speed is equal to distance over time. Yeah. Okay, so now let's say I went up in speed, I think. So this is important. If I had driven each kilometer 1 minute faster, each kilometer 1 minute faster. So for 90 kilometers, that would be 90 minutes faster, correct? So that would mean instead of 3 hours, 90 minutes faster would be 1.5 hours. And we're still talking about 90 kilometers. Now using the speed equals distance formula, you can figure out the speed this time would be 60. I'm just giving an example using the information in the question using numbers. Now we have to calculate this guy, but for 3 hours. So 3 hours, but at the same speed. Yeah, constant speed. So again, at 60 kilometers per hour. And distance, therefore, would be 180 kilometers. Okay, so we have to do pretty much the exact same thing, but instead of what I gave, which I started with 30, we have to start off with x this time. Yeah, we got to start off with x. So here we go. Let's do the same thing. And because I've already done it, it should be a little bit more digestible or understandable. Speed, distance, and time. So this time we're working with the information in the question. The distance they gave me this time is x. So I'll put the x here, x kilometers. The time is 3 hours. That stays the same. And the speed, that is what I'll calculate with that formula. So it'd be x over 3. X over 3. Okay. Now we are basically want to go faster. We have to go for each kilometer. I have to go 1 minute faster. So I have to subtract from this 3 hours 1 minute for each kilometer. So is x kilometers. So in terms of hours, that would be x over 60. Yeah, very similar to what I did there. Just this time I have x. And this stays x. And this speed would therefore be x over the time, which is 3 minus x over 60. Okay. Now we get to the final part, which is driven 30 kilometers farther. So that this becomes x plus 30. 3 hours, so that's 3 hours now. And then this s here would basically be x plus 30 over 3, according to that formula. And then just like here, how this was the same as this, this therefore has to be the same as that. So that means x over 3 minus x over 60 is the same as x plus 30 over 3. And that will allow us to calculate x. So that's the setup. So here we go. Cross multiply, we get 3x. 3 minus x over 60 times x plus 30. And then let's expand this. 3x. What do I do here? I got to multiply top and bottom by 60, right, to get a common denominator. So that's going to be 180 minus x over 60, if that's correct. X plus 30. Cross multiply again, 180x, and then this we got to do the FOIL, 180x plus 180 times 30 minus x squared minus 30x. That's right. Oh boy, is this a quadratic? Let's eliminate it as much as we can. X squared plus 30x minus 180 times 30 equal to 0. And let's see if this factors. Hopefully it will. X, 60 and 90, I believe, would do it. Yeah, 60 and 90 would do it. And then it would be minus and plus. So x is 60. And there we go. That is the answer to the question. In the complete expansion of minus x to the power of 3 plus 3x squared minus 5x plus 7 all to the power of 2004, the first term is x to the power of 6012. And the second term is kx 6011 as the exponent. What is the value of k? Well, let's see. Let's make it a function, and the function is given. So let's write that out. Just that guy. Don't worry about the 2004 for now. And, where do I go from here? The first term and the second term. The first term, in the complete expansion, the first term, okay. So, oh boy. We're going to have to use Vietas. So, you guys know about Vietas formula, right? But the only thing is that this is a cubic. So it's not the standard one. This is ax squared plus bx squared plus cx plus d, that kind of one. And if I remember, for a cubic, the sum of the roots are minus b over a for using Vietas. So if I were to use that on that formula, minus b over a would be minus 3 over negative 1, which is 3. So the sum of the roots of this guy is 3. Yeah. So if I have f at x to the power of 2004, which is what we have up there, that'd be like f at x times f at x all the way times f at x. And there's 2004 of these guys. I just didn't write them in, obviously. And the sum of the roots of each of them is 3. So the sum of the roots of this whole thing would be 3 times 3 onward 3. And that's obviously 3 times 2004. So the sum of the roots of all these guys, sum of roots of, and that is of course 60112. Okay, now we go back to the original equation, and that was basically to the power of 2004, correct? And they've given you that the first term is this guy and the second term is this. So the first term is x to the 6012 and the second term is kx to the 6011, and then a whole bunch of other stuff that we don't know. But using Vietas, we don't really need to know any of the other stuff. We just use the sum of the roots. Sum of the roots would be minus b over a, so it would be minus k over 1. Let me see if I did that right. Yeah. And then we also know that the sum of the roots is 60112. So therefore, k is equal to minus 6012. And I believe that is the correct answer.